Welcome to the webinar. My name is Megan and I am training coordinator here at NeSI. Today we will be discussing troubleshooting on high performance computers. Specifically, we have Callum from our app support team who's going to share some tips and tricks on how to troubleshoot more effectively so that running jobs on NeSI goes as smoothly as possible. So before we get into that, there are just a few housekeeping items to cover. Callum will be presenting for 30 or 40 minutes, followed by 20 minutes or so of questions and open discussion. During the presentation, we ask that you keep your audio on mute if you're not speaking or asking a question. But if at any point in time you're confused or need clarification on what's being presented, you can type your question or comments into the shared Google Doc. The link is up on your screen, but I'm also going to post it into the chat right now. Here's the link to the Google Docs. So if you click on that, you will arrive at a shared document. Pop your questions or comments in there, and we have some NeSI staff who are monitoring that document and will answer you in real time. Otherwise, you can wait till the end of our session today to ask a question verbally during the Q&A session at the end. And last point, the webinar video and slides are going to be available on the NeSI website in the next few days. Those of you who registered for this webinar will get an email when that content has been uploaded. And one final note, if you don't want to appear in the webinar recording anywhere on accident, just make sure you turn your video to off by clicking the icon on the bottom left of your screen. So I think that's it for the housekeeping. I think we are now ready for our main event. Callum, are you ready?
Yep. Can you guys hear me okay?
Yep. I'll stop sharing my screen and then you can.
Just wanted to say, Megan, if anyone's got questions pertaining to like what's on the screen, can you let me know? Because I can answer that.
Sure.
There's not a huge amount of content, so I'm happy to answer questions as we go. Right, I will share my screen. Does that look right? Righto. So the goal of this is going to be, it's going to be a pretty sort of high level, general approach. We might do something more specific another time if there's interest in that. Now the plan was, oh, is my slides working? We're going to go through just some common errors that you might run into, or in what those errors might look like. Then we're going to cover some a methodology, so a set of steps that you can follow in the debugging process. And then finally, we're going to cover what the best way to ask for help is. Now, troubleshooting, this is a definition I kind of liked. It's a logical and systematic search for the source of a problem in order to solve it. Now, it's a pretty vague, troubleshooting doesn't necessarily have to apply to computing or HPC. It's just generally, an approach to solving a problem. It's a bit different from debugging. Debugging is generally specific to editing code. So we're focusing on troubleshooting today, not debugging. But if there is interest in going over, some debuggers like DDT or GDB, Valgrind, etc., that is something we might do in the future. But for now, this is going to be a pretty general coverage. Ooh. So I'm from the app support team. So there's like 6 of us, and it's our job to maintain and install software, manage project applications, monitor, report, also run workshops and training, advise researchers, and sort of most relevant to this, provide support. So if you have any issues, you're going to be talking to one of us. Right, now just going through some of the more common terms you might see when you're running into an error on the NeSI platform. First one is pretty self-explanatory. timeout, cancelled due to time limit, you're going to want to go back and look to make sure you've asked for enough wall time. It may seem silly to include this, but some people have thought it necessary to ask support tickets about that. Next one down is a pretty important one. See, all these terms here, kill, out of memory, is the errors you'll get if the system catches your program trying to use more memory than it's been allocated. That's not to say that that error will always appear if you run out of memory, but that's a pretty good sign. You've also got segmentation faults, which are another error that you might get thrown if you've run out of memory. Generally being a bit more specific, it means your code is trying to access memory that it's not allowed to. These will generally create core files, which are dumps of the environment at the time of failure. But again, just think segmentation fault, memory errors. The last one is SIGBUS, which is slightly different from a segmentation fault, and it's generally it's just been given the wrong address of memory. But again, these are all things that can happen if you haven't given your job enough memory. Another thing that can often cause these out of memory related errors is if you've set up your parallelization wrong. So if your code is using MPI and it's not supposed to, or you're trying to run your job in a configuration that doesn't make sense, memory errors are the most common things you'll run into. So generally that's going to be a good place to start. Now, probably the next most common errors is problems with people's inputs. So really common is people just putting spelling mistakes in their paths. You might think you're above spelling mistakes, but you're not, I assure you. This one here is something you might not think about that often, but especially if you're using a Windows or Mac machine, the line endings in a text file are different. So if you've edited a file on your local machine and then uploaded it to the cluster and tried to run a job, you might end up with all sorts of errors about, well, maybe just misreading it or specifically interpreter-related errors. And that's due to the fact that the Windows line ending is tab, enter, and the DOS one is, sorry, the Unix one is just enter. But you'll see this here is a common sort of symbol. This represents the, that's how Bash will print out a Windows line ending. So if you see that, top hat M, that's a sure sign that you've got some sort of line ending issue, or seeing -R-N printed out. There is a command that's really easy to run, DOS2 Unix, and then the file name, and that will convert all Windows line endings in there to Unix. So if you're even a little bit worried about an input file being the cause of your problems, there's no harm in running DOS2 Unix on it, just for peace of mind. Permission errors. If your program's having issues reading your inputs, you might have it in a directory where it's not allowed to be read from, especially if you've copied someone else's code and you're trying to read an input from one of their projects. Or maybe you just copied it over with the wrong permissions. Generally, this is a relatively simple fix. Might be a matter of just changing the path or adding the right permissions with a chmod. Now, I'm not really going to go into too much detail there, but that's just adding read, write, and execute to you, to a certain file. If you have, if you're pretty sure that the file is actually, it's not something you've written in your input that's wrong, it's generally good to confirm that the input file that you have on your local machine is actually the same file that you have on the cluster. And I mean, you can compare size or dates, but a really robust way of confirming that is using checksums, which are, I can go into that later if anyone's got any questions about it. But I would recommend using them if possible. You can also just put together a really simple test case, or get something offline, run it through your program and see if it works or not. I'm going to get into the procedure a bit more later. Slurm is generally pretty good with telling you if you're doing something wrong, especially when you're submitting things. So if you try and submit a job on a partition where it's not allowed, it will generally just tell you that. But sometimes you'll get a general SBatch error, QoS, which is quality of service, which pertains to a few other things. So it might be, you might be trying to run multiple debug jobs. Your project might be expired, or you might have put an expired project as the account. That's the only one I'd really focus on, because most of the time it will just tell you straight up, that's an invalid node combination. A lot of people run into issues where their jobs just don't start, and best way to check that is by using the SQ command. And again, I'm going to cover that in a bit later, but that will just tell you straight up what the reason your program is waiting. That's often just the start, because you'll then have to fix whatever that problem is, but at least you know what's going on. And another common issue is people's jobs running and not producing any outputs. This command here, nn_check storage quota, will tell you how full your project and home directory are, and no backup directory. Because often if you've completely filled up your quota, it won't be able to write in. And that doesn't always cause a problem. That doesn't always cause an error. You might just not have anything there. Also, did the job start? Sometimes you don't have any outputs because your job hasn't run.
Yeah.
I would check that one first.
Perhaps it did run and it got cancelled right away.
Yes. So check that one. Save yourself the embarrassment of opening a support ticket. Not that you should feel embarrassed for opening support tickets. I want to emphasize that. Where did I put this? And just a few assorted module-related problems. Now, if you've done any sort of NeSI introductory material, you'll know a bit about module files. Often people will have in their script, they'll be trying to load, they'll have a typo in there, or they'll be trying to load a piece of software which isn't there. They'll get this: following modules are unknown. We don't actually have a piece of software called software on the platform, so that's why I got that one. A lot of people get confused. They load a module and expect something to happen. Loading a module is sort of like, you've added the program to the things that can be accessed from the cluster. So loading a module on its own doesn't necessarily do anything. You'll have to then do a command. The opposite is doing a command without loading the module. You'll generally get this vague command not found error. So check that the module is actually there with a module list, or maybe you've just got the command wrong. It's not working the same as on my desktop. That's a very wide and difficult to debug one. So easy thing you can try is just using a different version, or again using a known script. But if that doesn't help, then you're going to have to do some more serious troubleshooting. Now, this isn't supposed to be necessarily a reference, just I wanted to get some of those terms into your head. Now, there are quite a few different sort of models for troubleshooting methodology. I tried to pick one that seemed relatively pragmatic. and not too sort of abstract like a lot of them are. Obviously, it's something that becomes a bit more intuitive when you practice it. So it might seem quite weird to actually see it broken up into steps, but it's a good way to, a good framework to start with if you're a bit lost. Troubleshooting is an iterative process. So you'll test one thing, you'll test another thing, you'll test another thing, and you're, striking off possibilities of what the issue could be. So we've got here identify, hypothesis, test, solution, verify, and then document. And I'm going to go through those now. So identify. So the first thing you're going to need to do is actually find out what has gone wrong. So again, I know that sounds like a sort of silly thing to ask, but quite often you'll make an assumption about what's gone wrong rather than actually properly looking through the job failure and saying, this is actually this is the actual problem. This is actually what's stopping me from going forward, as opposed to just, aesthetic error, a non-functional error. You'll quite often get one error will lead to cascading errors. So, everything else fails because of your first error. So you want to try and find what that root cause was. And you'll be doing this by looking by information gathering. So Slurm is a great first source for collecting information, and then output logs. So a couple of Slurm commands here that can give you some info on your job. saccount is probably the one you're most familiar with. So saccount shows you all of the jobs that have entered any state in the past day. So any job that you've submitted in the past day, any job that's finished in the past day, or cancelled, or for any reason finished, will show up there. You can extend that back with flags, but we're not going to worry about that for now. So this will give you a sort of general summary of what happened. You'll notice there's 3 lines here, all with the same job ID. So this is the parent job, this first row. And then the next 2 are each stages of that job. So they might have a job state independent of the other ones. So we can see here the extern state completed fine, but then the batch stage had an out-of-memory error. So yeah, you notice I pointed out state here. That's just telling you if the job is pending, if it's running, or in this case, if it's out of mem-o. Quite often, things will be truncated off the end here. If you really, really need to know what the end of that word is, you can change your saccount preferences to make those, columns larger or smaller. But I mean, that's generally pretty unambiguous. Important things you're going to want to look at: check your time limit. Check, is that actually the amount of time I gave it? Compare that with the elapsed time. So this one ran for 7 minutes, 24 seconds. It's very useful to compare the elapsed time with the total CPU time. So the total CPU time was 2.5 seconds. Now, on a job that ran for 7 minutes with 6 cores, we would expect 35? No? We'd expect a lot more than 2 seconds.
About 40.
About
40 minutes.
We would expect about 40 minutes of elapsed time, assuming our job is running efficiently. So something is definitely not gone right here. If we're 7 minutes into the job and only run 2 seconds of something. So this column here is how many threads it was allocated, and this one here, tasks. Whoops, the next one, tasks. Not going to go into the difference between threads and tasks. If that's relevant to you, we've got documentation on that. Required memory, that's how much memory you asked for in megabytes. And max RSS is how much memory that task peaked at. So we can see here this task peaked at 1, 2, 3, 4, 5. Is that 3 gigabytes? Have I got the right number of zeros there?
Yes.
Yes, that looks about right. So it peaked at 3 gigabytes, but I only asked for half a gigabyte. So,
But you asked for half a gigabyte per core. So if you have 6 cores, then that's your 3 gigabytes.
okay, but if you see your max memory about the level of your required memory, that's reason to be suspicious. I would also be suspicious of any of these categories that have a default value. So the default value, the default amount of memory is 512 megabytes. Anytime I see that, I immediately assume that you just haven't set memory. That might be because you forgot, or it might be because there's a typo in your Slurm script and it's caused it not to be read. Also, the default time limit is 15 minutes, and the default amount of threads is 2. So any of those is a red flag for me. So those are the main things you're looking for in S account. If your problem is you can't figure out why your job's not starting, that's when you want to use SQ-U and then your username. So you can see here, most of the stuff is not super relevant. You'll sometimes get a start time, which is when it expects your job will run. But this one here, reason. So this is just telling you the reason your job's not starting. Now, normally this will be priority or resources. So priority means, you know, you're in the queue, just wait. Resources means you're at the top of the queue, but there is still jobs running on the nodes where you're going to go. That one, job held user, means I held my job because I wanted an example. So you're probably not going to see that one that often. But now the last one is NN_SEFF, which only works on a job that's finished, which will sort of do a lot of the math I was showing before for you. So we get a state here, you know, what state did it end in timeout, our cores, tasks, nodes, job wall time. It used 100.7% of the time we asked for. So that's pretty obvious what happened there. But also CPU efficiency, which is that calculation I was doing before, and memory efficiency. So that can be a good place to start as well if you want to just get some info on your job. Right. Now, output logs. So any process running on in a Unix environment is producing a standard error and a standard output. So standard output is just whatever is usually printed to the screen, printed to terminal. And standard error is a special stream reserved for things going wrong. So in your Slurm script, you've got two headers here you can set. So -- output will send the output of standard output to that file, and -- standard error will send the error there. If you haven't set a standard out, it will get sent into this file called slurm-jobid.out. So if you don't recall setting a path, you'll find a file like this, slurm jobid. If you haven't specified standard error in the slurm header there, it will just go into your standard output, which is generally more convenient because you don't normally need to separate them. It's nice having all of your output in the same place. Now, it's important to note that the paths here can be relative or absolute. So a relative path just means with respect to where I currently am. So if I'm in my project directory and my path is, you know, just output.txt, it's just going to be dumped there because that's where I submitted it from. That's a relative path. Whereas an absolute path is specifying right from the top. So /NeSI /project /UOA blah 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 output name. So if you're having difficulty finding your outputs, bear in mind that it might have been because you were in a different directory when you submitted it and the path was specified relatively. I generally recommend people set their paths absolutely, because that way there's no sort of ambiguity as to where that output file could be. and you won't spend time, hunting through folders looking for it. If, however, you set a path that doesn't exist, you're not going to get an error. All your output's just going to, go into the void. That's probably one of the more inconvenient things that can happen. So it's good to double check those paths. Now, the standard output isn't necessarily going to be the only relevant log to you. So like I said before, that's just what would have been printed out to you anyway. A lot of programs will have their own dedicated log files. That might be a duplication of what you're seeing, or it might contain more information. It really just depends on the program. So if there are other log files, you're going to want to look through them as well. And super important, don't delete your error logs. If you have something go wrong, please keep them. We're going to want to see them if you open a support ticket. And if you're troubleshooting, it's worth keeping your old error logs around so you can compare them with, one from your latest test to see if something has actually changed. There's no harm in making a new directory and just chucking your old one in there and then, putting a new one in a new directory. That way you don't lose any information. Right, just lastly, so it's pretty sort of intuitive that the last thing of your log is the last thing that happened. Generally, you will start from where it failed and then just step backwards through your script until you find what you think is the problem. This is sort of similar to a stack trace or a trace back. So a trace back will print out the parent function followed by any child function followed by a line number of where the failure is. So it starts off at a high level and then gets more and more specific until it's telling you the root cause. I think I've got an example of that. You might need to run your job again to collect more information. A lot of processes will have a verbose flag. Obviously, this is process dependent, but that should print out a lot more information for you. Or you could do it the old-fashioned way and just chuck print statements throughout your code to try and gather some extra info. I put this here because there is an important distinction between a warning and an error. They're not just, they're not synonymous. A warning generally means, the program recognizes something has happened abnormally, but it's going to keep going. It thinks there's a reasonable chance you could continue to run the code. Whereas an error is saying, just, nope, can't do this anymore, we're ending. A warning might, precede an error, but it doesn't necessarily have to. It could just be, the warning could have nothing to do with your problem. I'm going to bring up an example now. Which one did I want to show first? Can you guys see my terminal? Yep, cool.
It's very small. Can you make it bigger?
Can I make it bigger? I can. Give me a second. I opened the wrong terminal. Okay, is that a bit more legible, bigger? Okay, oops.
Yep, that's good.
So, please ignore my really messy home directory. Right. Oh, I was trying. This was supposed to be my example of showing a trace back. So, the high-level problem, followed by more and more specific issues. I think the one I meant to show here was oops. So see, we've got a warning here and then an error. So the program can continue to run after the error's been thrown. Now, this is a good example to try and get your input on what you think the root cause might be in this error log. So any ideas about what you think the problem is here? Any ideas? Don't make me answer my own question. That's just sad.
Maybe you need to give a reward, Callum. What's the virtual high five?
We'll give you 10 CPU hours to the first person to make a suggestion. I can't actually promise that.
Well, I do note that you're given further information on where to look.
Yes, yes. That would be a good next step.
Other than that, I could offer a surmise, but that would probably not be very useful. Well,
so generally we're going to want to start at the bottom. So error, user library, libn user failed to build. Oh, okay. So it's a library issue. Then we step back one. Unable to locate the compilers. Okay, so couldn't find the compilers. Then a bit of a right-hand turn here. Missing UDP file, permission denied, and then back here again, permission denied. So you might rightly assume that this is something to do with some missing library here, but I'm cheating because I know the actual answer. The root cause here is actually that it couldn't read your input file. The permissions on the input file were not correct, and that's not considered a fatal error because I guess there are some situations where it might not be. So we've just got a warning here saying couldn't read the file. But then that causes something else to happen, and then we get a proper error here, which actually doesn't seem to have much to do at all with the root cause. So I just wanted to show an example of one, how a warning can actually be your main problem, and two, how you can get sidetracked by other things. So I could spend 2 hours debugging library directories, rebuilding things, and make no headway. So that's why.
Callum, there was also a message about the missing Intel compiler, so that didn't play a role in that particular case. I mean, if the user was building a library, then and cannot find the compilers.
No, this doesn't appear at all if the permissions are correct. This is what I mean by it seems quite unrelated. I think it might be if it can't build it, it might default to the next compiler. I don't know exactly why that error comes up. My point is just that it seems to have not much to do with the original problem there. So
it's worth noting, though, as you look at it, that the ultimate error is something about libAnts user, and earlier there was something that went wrong while it was trying to create libAnts user.
Yep, but we're not going to debug the library issues here. It's just
but what I mean is that in this particular case, because the error is user library libAnts user failed to build, but further up there was creating libAnts user library with routines, and then there was an error message. There is a potential logical tie-in there. That's the point.
Right. Well, I mean, some more context. This is actually the building of a user-defined function. So it would be during the compiler stage, I guess, where it first tries to actually read that. So it makes some sense. Anyway, we don't actually have to fix this. It's not a vital issue. I just thought it was a good example. Right. Sometimes your output file might be really, really long. So using the commands tail, so tail will, actually I'll do an example of that again. So don't look at that.
Your terminal is very
Oh,
tiny.
oh yeah, I'm using the wrong one again. It's probably not worth it. But yeah, so tail is a command that's used to print out just the end of something. So you can say, you know, tail your file, and I think the default is like 10 lines, but you can say tail space -n and then a number. So 100, show me the last 100 lines of my output log. grep is a method of searching. So you could say grep error and then your output log, and it will print only the lines with error. Often that's not super helpful because you want to know what's happening around it. So there's a handy flag for that, capital C, which stands for context. So you can say grep capital C 20 error and then your file, and it will give you 20 lines before and 20 lines after any reference of an error. Again, don't have to memorize that, but just, you know, you can look at the man pages for grep if you find yourself needing to do something like that. Right, so we're assuming we've concretely found, well, what we think is the actual problem, not necessarily the root cause of the problem, but just what the problem is. So then we want to come up with a hypothesis. Most of the models just said theory, but that bothered me because it's not actually a theory, it's a hypothesis, so I changed it. So yeah, a few things, few starting points. What's changed since it last worked, if it's worked before? That's a pretty obvious one. If not, should something have changed? Have I copied this into a new environment and forgot to change the paths? Have I taken this off someone else and forgot to change, you know, a user? Or, you know, is there something that you should have changed due to the circumstances but haven't? Does this seem to be an external problem or an internal problem? Is it your code's sort of collapsing in on itself, or is some other process interfering and stopping it? If your problem is intermittent, so you can't seem to, you can't replicate it every single time, try and figure out what the pattern is, what the common factors are in its failure. That's going to be the first place you want to start, if that's the case. And, you know, ask around, ask Google. Google's your friend. Getting proficient at Googling things will save you a lot of grief. And yeah, try not to make assumptions, especially not assumptions about your own competence. Those are the worst assumptions, because a lot of the time it will be a really silly spelling mistake, and you'll kick yourself for not seeing it. Now, I've got an example here.
Just a heads up, Callum, if you can wrap up the presentation in like 5 minutes or so we have enough time for questions.
Wow, okay, right, 5 minutes?
Yeah.
Okay, well, this was my example.
Roughly.
This was, I thought, a good example. This is probably a good example of when to use grep because it's a long file. So using this file here, I'm not going to ask for user input because I don't expect it, but what might be the hypothesis as to the cause of my error? So in the first step, I would have identified bus error. I'm going to say that a bus error is the problem here. Now my next step is to ask, well, what do I think has caused this bus error? And a reasonable first step would be, you know, I could give it some more memory. That's something that was in that table back there. Now, I actually know because I made the case that the error is caused by trying to run a non-MPI job on multiple nodes, which is probably the other main case that causes bus errors. So, you know, there's multiple hypotheses you could come up with. Just pick the most likely one and then go to the next step. Sorry, that's bad. So next, once you've got a hypothesis, so you know what you think the cause of the problem is, you need to test and actually confirm that that is the case. Generally, you want this to be in a controlled environment, so you can tune as many of the factors as possible, and you want to try and control as many of the independent variables as you can. If there are variables that can't be controlled, you're going to need to at least acknowledge and think about any possible effects they could have. Now, you can use positive or negative controls. Now, what I mean by that is, say your hypothesis is that your input file is wrong. The first thing you could do is you could get a input file that you know works, substitute that into your workflow, and if your hypothesis is that the input was the problem, then you expect it to work. The other thing you could do is you could take your input and put it in a workflow that you know works on other things, and then you expect, if your hypothesis is correct, that that fails. So there's always two ways to test a variable. Bear in mind, though, that there might be multiple factors, and they might be independent of each other. So having one test proving one thing is not always enough. You might have to sort of work in multiple dimensions. You want your tests to be run, run in a way designed in a way that can be run quickly if you want, because you're going to be doing this lots of times. It's best not to assume that, oh, yep, I've got it. This is definitely the one. I'm just going to resubmit my 15-hour job. It's best to, just pick the little bit, confirm that first. You can, if it's not using much memory or not going to run for that long, just run it in the login node. If not, you're going to want to decrease the resource usage on it so it gets through quicker, or using QoS debug or partition pre-post flags to just get that through quicker. Then if your test is correct, if your test is, shows that your hypothesis to be wrong, then you're going to want to go back to your theories, come up with a new one, and then test that. If it shows you right, then you're going to want to move on and try and make a solution. If you don't really know, then you obviously didn't design your test very well. So yeah, a few sort of examples is you might think something's wrong with your input, things you could do to test it, run it somewhere else, use a verified input, compare checksums. If you think there might be something wrong with the parallelization, run it in serial, see if that works. We talked about memory. If you think the software is broken, try using a different version of the software, or run your input file on another one just to confirm that it's not that. Oh yeah, and check patch notes. You might find out that someone has already found the error, and it'll save you a lot of time. Right. So you've identified the problem. You've come up with an idea about why that's happening. You've confirmed that that's the case. Now you have to actually fix it, unless you find the patch that already fixes it for you. That'll save you some time. You're going to have to come up with a workaround or a hack. I recommend keeping the broken version untouched and make a copy to do your fix on, because it's good to have a record of what you've been changing, so that if you have to do multiple fixes, you could make sure you don't repeat yourself. You might also have to roll back if your solution makes things worse, which happens sometimes. And then once you've got your fix, you need to actually confirm that it works. There's multiple different types of verification you can do. You can test just the component that you fixed on its own, see that that works. You're going to want to also test that it fits into your job as a whole, and then you're going to want to verify the whole job. I'm not saying you have to do all of those tests every single time. It's just I want you to know that they're there. If the problem's still there, you might want to think about, rethink your solution. You might not have done it properly. If you cause a new problem, then you're back to step one. We need to identify what this problem is. It's also possible that you just misassessed what the cause of the problem is, and you've just fixed a, one of the downstream errors. It is also possible that there just are multiple independent issues, and you're just going to have to fix this other one now. Did the job get further along? Did it stop at the same point? Did it stop earlier? Generally, getting a new error is progress. I always consider it progress. So don't be too, upset if your troubleshooting just gets you another error. Now, this is very optional, but if you're a good person, you will write down what you've done, document it somehow. If it's open source, you could submit a patch, or just submit make a comment on their GitHub or whatever. If you're a nice person, if you're a good citizen. Right, we're just going to go through how to ask for help real quick, because I think we're running out of time. Generally, it's good to, before you open a ticket with us, just put a little bit of effort in solving it yourself. Just go through some of those troubleshooting steps. Check our documentation. Make sure we haven't already written up how to solve the problem. Google it, ask a friend, coworker. That sort of comes under the troubleshooting stuff. Is the stuff that is pretty basic and would be covered in our intro workshop? If so, maybe consider attending that. It's very annoying when people open a ticket where the error will be very sort of simple instructions about how to fix the error. So make sure that's not, you're not just sending us that, because that you shouldn't be ashamed to ask for help. That's the moral of the story. Generally, in your ticket, you want to include as much info as you can about the troubleshooting done so far and how that came out. Basic context of the job. Is this 1 of 100? Did it work yesterday, or is this the first time you've run it? Job ID, so we can look at the Slurm stuff. Tell us, show us, point us to where it was running. Preferably that's somewhere we can actually access. If it's in your home directory, we won't be able to access it, so you should probably move it out. And any other information we might need in order to replicate it. Yeah, don't expect us to solve it immediately. So yeah, don't email us the night before your paper's due and expect us to solve it. We can try, but no guarantees. Being able to Google stuff well is a incredibly important skill in the modern world, and is a very important part of troubleshooting. But you're going to want to make sure you're not just copying your whole error. You want to remove the context specific stuff, like where your software is running, what your username is, what your file name is. It's generally best to include your software name. That will narrow down the results quite a lot. There's a few handy tricks you can use. The asterisk is a wildcard, so it can be substituted for anything. And using quotes, we'll say this has to be in the output, exactly like this. No, no fuzzy searching. These words need to be in it. You're going to want to, generally try and rely on the more high quality resources here. Stack Overflow, GitHub, the actual documentation, or NeSI documentation. So yeah, this is an example of a bad search string. I've just copied that straight from my error log. That's probably not going to get me anything. Whereas this here, I put the name of the software. I've identified what I think is the actual error. Failed to check out license, solve. You could argue that maybe I shouldn't include this bit because that could be context specific, but I've decided to include it there. That's much more likely to get you results than the first one. Ben, Megan?
Great.
Did it get through on time?
Yeah, no, perfect. We have about 10 minutes now for questions. So if anyone has something that came up for them while they were watching the presentation. Feel free to unmute yourself now and we can kind of chat about a few things before we wrap up. Or even if it's not a specific question, it could be something you just want explained a little bit more in detail, or an error that you've gotten that you might want help with, or something. Anything, really. While people are thinking, I'm just going to put up some wrap-up content on the screen so people can see where to get help.
Got a question.
Mm-hmm.
Well, thanks, Callum. That was awesome. I learned a lot.
Oh, thank
I
you.
was just wondering if those standard error messages that you mentioned in the beginning, if you have somewhere on your NeSI homepage, like a list of them and what they mean.
By standard errors, you mean?
Well, like the and SIG bus.
The
right.
common errors.
Common errors. Well, oops, where was my slides? That list I had at the start was sort of an amalgamation of what you might get from, so for example, timeout.
Sorry, Callum, I stopped sharing your screen. So if you're showing anything, you need to reshare your screen.
Okay. This one here. So yeah, sorry if that wasn't terribly clear, but this one here, timeout, that's a slurm error, whereas cancel due to time limit is what would be printed in the standard output. Out of memory is the slurm error, where these are all variations of what will be printed. You can definitely get a list of all of the slurm errors, but often this will, the actual wording of it will depend on the software. I just wanted to put up as many variations of what different software prints out.
Okay, thanks.
But if it would be useful, we might put this sort of thing on a documentation page, just like a little cheat sheet. You can find the list of all of the slurm states by doing man slurm. You'll have to scroll down a bit, but it'll tell you a list of all the states and what they mean.
Okay, thanks.
Any other questions or comments?
Yeah, so here's a list of states you might get. You'll generally only see one or two of them, but
I have a question for the attendees, if that's permitted.
Sure.
What would be the topic that you would most want to follow up this one with?
Yeah, we would like to know that. That would be good.
Hi, this is Johnny. Can you hear me?
Yep.
I'm just responding to that question from Ben. So I can't think of anything right off the top of my head, but I was wondering if there was, I don't know, should we put some, if we have an idea after this meeting's ended, where would we put that?
Oh, you could email me at, I'll put the training email in the chat if I can find it. Where is that chat box? Ooh. 1 second. It's training@nesi.org.nz.
Okay, great, thanks. Yeah, yeah, I'm sure I could think of something.
Yeah, and yeah, we would love to get ideas, because the more relevant it is to you guys, I mean, the better for everyone.
Yeah, Johnny, if you just, you know, you could also just chuck it on the end of a ticket, if that's easier, and I'll pass the message on. But
sure, great, thank you.
Yeah, really, if you get it to someone at NeSI, it'll probably come to me, and I can make sure the right things happen to get a webinar up or something.
Yeah, there's not that many of us. It's not, you know.
We talk to each other.
Yeah.
Great, thank you.
There is one question, another one that came up in the question document. It says, could you maybe show how to run the OpenFOAM sample script? Did not manage it yesterday.
Ah, okay. The sample script, it might be a bit out of date, but I did make that one. That's probably something better to talk about in a ticket, because it's only really going to be relevant to OpenFOAM people. Who asked that question? Because I'm happy to, we can have a chat after if you want.
It's in the document.
Oh, it is? Okay.
So,
okay.
So we have just 3 minutes left. I'm just going to pop up the wrap-up slides and wrap up now so that we don't go over time and everyone can get on with their day. I'm just going to stop sharing your screen, Callum.
Yep, that's good because I'm about to check my emails.
Let's see, where is it? Okay. Okay, can everyone see that just fine?
I did also see in the chat channel, Megan, that someone has requested a debugging seminar.
Oh, right. Okay. Great. Okay, I'm making a note of that.
Any particular sort of language that you'd be interested in?
So you mean like debugging for?
Yeah, so like debugging C, debugging Fortran.
Muna, can you comment on that? Okay, she says the one she's doing is Linux. I think what she means is the bash shell.
Okay.
Cool.
Although I'm sure that debugging could be extended to include interpreted languages generally.
Mm-hmm.
Cool. Great idea. I like it. Okay. So as we had said before, guys, if you have a question at all, I know this was about troubleshooting, but if you are really stuck and you can't figure out what's going on with your code, email support@nesi.org.nz anytime with questions. We are more than happy to help you. You can also check out our documentation at support.nesi.org.nz. And the webinar slides and recording will be posted to the website. If you registered for this webinar on Eventbrite, you'll get an email once that's ready.
I think.
One last thing, guys, before you head out. We do have a few more webinars for this beginning of the year quick tips webinar series. Here are some of the topics that we're going to be covering. If you want to get notified of these upcoming webinars, you can subscribe to the NeSI mailing list if you're not already by clicking that link. I need to post that in the chat. Jana, are you still on the call? Could you post that in there for me? Cool. That'll arrive in the chat soon. But you can subscribe to get our newsletter or just to get emails for when we do webinars or other training events. And you can see on the right-hand side of this slide, if you have an idea for a topic, email training@nesi.org.nz or open a ticket. That's it from us today. The webinar is over. Thank you guys for coming along.